Question 12. Explain how Pascal's triangle can be used to determine the coefficients in the binomial expansion of x plus y to the n. So we want to make a general statement, but I'll start off with just giving Pascal's triangle. And then to get the next row, we add these two coefficients. So it'll be 1, 3, 3, 1. And then I think this will be enough. It'll be 1, 4, 6, 4, 1. All right, so what does this mean? Okay, if we're doing x plus y to the 0, we get 1. Anything to the 0 is 1. If we do x plus y to the 1, obviously that's just x plus y, right? So our coefficients, right, are 1 and 1 respectively. Now when we do the expansion of x plus y squared, now the triangle's more helpful. We get a 1 from the first coefficient, and then we get a 2xy from the second coefficient, and then the 1y squared from the last coefficient. So right, these coefficients over here correspond to these values. Okay, I'm going to do one more, and I think we could probably write some kind of concluding statement here. X plus y, cubed. First term would be 1x cubed plus, and now we're decreasing our power by 1, and it's 3 because that's the coefficient in the triangle. X squared y plus 3, I'm on that row, xy squared plus 1y cubed. So again, what do you see? You can see that it corresponds to these 4 coefficients right here. So we got a little bit of an adjustment to make. What we want to note is when the exponent is 3, we want to use row 1, 2, 3, 4. We want to use row 4. So in order to write a general statement here, okay, and I could just back up for a second using a bit of engineer's induction. If the exponent is 2, we want to use row 3 of Pascal's triangle. Okay, so there's a couple ways we could write this. The way that I'm going to choose to write it is to say the nth row of Pascal's triangle can be used to give the coefficients of, and we got to make that adjustment. It's x plus y, and right, 4 corresponds to 3, 3 corresponds to 2, so our variable n would correspond to 1 less than that, n minus 1.